The Great Cosmic Crisis. Is everything we know about the universe wrong? Milky Way, when even Nobel Prize winners are baffled. In the world of astrophysics, few statements are more shocking than this. We may have completely misunderstood the universe. And yet, this is precisely what Nobel Prize-winning physicist Adam Riess has suggested in the wake of recent cosmological observations. A pioneer in studying the universe's expansion, Riess now finds himself at the forefront of a deepening cosmic mystery, one that may force us to rewrite the very foundations of modern astrophysics. With the help of the James Webb Space Telescope JWST, the most advanced space observatory ever launched, scientists are peering further and more clearly into the early universe than ever before. And what they're finding is unsettling. Galaxies that are far too massive, far too early, and expansion rates that defy our established theories. Stopwatch the Hubble tension, a cosmic disagreement. To understand what's at stake, let's begin with a deceptively simple question. How fast is the universe expanding? Since the 20th century, we've known that the universe is expanding, a discovery credited to Edwin Hubble, who observed that galaxies are moving away from us, with more distant ones moving faster. This observation led to the formulation of the Hubble constant h, a number that defines the expansion rate of the universe. But here's the problem. We have two very different values for h, depending on how we measure it. Telescope Method 1. Cosmic Microwave Background, CMB. One method looks far back in time, just 380,000 years after the Big Bang, by analyzing the cosmic microwave background radiation, a faint glow left over from the early universe. Using data from satellites like Planck, this method yields a Hubble constant of h is almost equal to 67 kilometers per second per MPC. Ringed Planet Method 2. Local Universe Measurements. The second method focuses on our cosmic neighborhood and involves observing Cepheid variable stars and Type Ia supernovae, both known as standard candles, for measuring cosmic distances. These observations, pioneered by Adam Riess and others, give a higher Hubble constant. H is almost equal to 73 kilometers per second per MPC. Warning: the discrepancy, the Hubble tension. These two methods, both scientifically sound, give results that differ by about 9%, a significant amount in cosmology. And as measurements become more precise, the discrepancy becomes harder to dismiss. Initially, some scientists hoped that the tension was caused by measurement errors, especially in the older Hubble Space Telescope, HST data. But when the James Webb Space Telescope remeasured the same Cepheids and standard candles with 100x greater resolution, the results remained the same. The Hubble tension is real, and it may signal new physics. Shooting star Adam Riess and the JWST revelation. Adam Riess and his team at Johns Hopkins University undertook a monumental task. Use the JWST to recheck every possible point of failure in the Hubble data. Using Webb's near-infrared camera NIRCam, they captured high-resolution images of Cepheids across dozens of galaxies, hoping to correct any previous observational mistakes. The result? The James Webb data matches the Hubble data exactly. Adam Riess. This means the tension is not due to observational error. It's a fundamental flaw in our understanding of cosmology. Puzzle piece. So, have we misunderstood the universe? That's what some physicists are beginning to ask. One radical idea is that gravity doesn't behave the way we thought it did. According to Einstein's general theory of relativity, gravity shapes the universe, curves spacetime, and guides the motions of stars and galaxies. But what if Einstein's equations break down at cosmic scales? Milky Way cosmic bubbles and an uneven universe. Some researchers propose that the universe is not as uniform as once thought. They suggest that our solar system sits in a mass-deficient bubble, a large underdense region surrounded by denser cosmic structures. In this model, galaxies on the outer edge of the bubble appear to move away from us faster, creating an illusion of a faster local expansion. This could reconcile the two Hubble constant values without new physics. However, this leads to another problem. The standard cosmological model lambda-CDM doesn't allow such bubbles to exist. It assumes a homogeneous universe, where matter is evenly spread out on large scales. Atom symbol, a radical idea. Modified gravity. Enter modified Newtonian dynamics (MOND), a theory proposed by Israeli physicist Mordechai Milgram in the 1980s. MOND tweaks Newton's laws to better explain certain galactic behaviors without dark matter. Though largely dismissed for decades, MOND and other modified gravity theories are gaining renewed attention, particularly because they predict the existence of these cosmic voids and bubbles. If MOND is correct, it could resolve the Hubble tension, eliminate the need for dark energy, and redefine gravity itself. Cyclone early galaxies that shouldn't exist. As if the Hubble tension weren't enough, JWST has uncovered even bigger surprises. In July 2022, Webb detected a galaxy named JWST Z13-0, which existed just 290 million years after the Big Bang, making it the oldest and most distant galaxy ever discovered. Nicknamed a universe breaker, this galaxy shouldn't exist. According to standard models, the early universe lacked the dense matter required to form such a large galaxy. Galaxy formation was thought to be gradual, taking hundreds of millions of years. Yet JWST found multiple massive galaxies, some with more than 100 billion solar masses, existing within 500 to 700 million years after the Big Bang. This flatly contradicts established models of galaxy evolution. Brain, the standard model under siege. According to our best theories, early galaxies should have formed through the collapse of dark matter halos, gradual accumulation of baryonic matter, normal matter, slow star formation over billions of years. The problem? These baby galaxies look like mature galaxies, similar in structure to the Milky Way, despite being just a few 100 million years old. To explain their presence, we'd have to assume matter was 5x denser than current models suggest, or unknown ultrafast formation mechanisms exist, or the Big Bang timeline itself is flawed. Bar chart James Webb versus Hubble. Who do we trust? Some experts, like Julian Munoz from the University of Texas at Austin, urge caution. His team points out, if there were 10x more dark matter halos, JWST should detect 10x more galaxies. But Hubble, despite its lower resolution, didn't detect this excess. Therefore, maybe we're misinterpreting the Webb data, not the universe. But make no mistake, JWST is vastly more powerful, offering sharper, deeper images that could still expose critical flaws in past interpretations. Telescope, a cosmic reckoning on the horizon. We now stand at a crossroads in astrophysics. Two central pillars of modern cosmology, the Big Bang model and general relativity, are being challenged by real observations. JWST has just begun its mission, and its findings are already shaking the foundations of what we thought we knew. We must now consider possibilities that were, until recently, confined to the fringes of science. Could gravity behave differently on cosmological scales? Might we need an entirely new theory of matter and energy? Is it possible the universe didn't evolve the way we thought? Dizzy the future of cosmology. In the coming years, a new generation of observatories, including the Euclid Space Telescope, the Nancy Grace Roman Space Telescope, and future CMB missions, will further probe these mysteries. Meanwhile, theorists will continue refining models that might integrate MOND, quantum gravity, or entirely new physics. This is a revolutionary moment in science, not the end of our understanding, but the beginning of a bold new journey to uncover the universe's deepest secrets. Megaphone conclusion. The age of answers is coming. When a Nobel Laureate says we may have misunderstood the universe, and when telescopes reveal galaxies that shouldn't exist, it's clear that a cosmic shift is underway. Whether we are on the verge of rewriting Einstein, redefining the Big Bang, or merely discovering errors in interpretation, one thing is certain.